Is there a reason why the code is only showing the solution as 0, 0? Like it just can't handle the circle also being a critical value?
Yeah, so when you solve for that, you're only solving for 1 point. So you're not going to get the whole circle when you solve for the x and the y. So you're telling it only to give you the solution x comma y. That's a point. 0, 0 is a point. The circle is, to be the whole circle, you're going to have it actually be the whole circle as a point, which is not possible, right? That's why it can't give it to you. That's why I have to use polar coordinates.
And that's what we're about to do.
That's what we're about to do. Buckle up.
Oh.
I'm just going to warn you this. Don't try to do these kind of computations while watching the Rangers game at the same time, because you'll have to go back and correct all your mistakes.
That was a pretty crazy game last night.
It was. I was holding my breath. I think I ruined this, messed this up. Okay, so you should have thought on Mathematica. That's what you should get. So something should be telling you, wait a minute. What's going on? I got one equilibrium point. It's kind of like Vanderbilt. It's got one equilibrium point. It's down at the origin, but I can see on my computer that it's got more complicated behavior. So it looks like I start inside that circle. If I'm close to the equilibrium point, what's supposed to happen according to your pictures? It moves away, right? So what should you get from the 0, 0 stability analysis? It's like having the answer manual with you. Why wouldn't you do what you just did? Put it on the computer first and see what happens. Okay, so let's see. Step 2. That was step 1, find the equilibrium. There's only one. Step 2, find the Jacobian. Derivative of the first side. Everybody, I hope, knows power rule. Otherwise, we're going to have to send you back to 104, right? So where are you going at? Just think if you went back to 104, you would be the top student in the class. Although sometimes people keep taking the class over and over, and I just wonder if they tried not to learn anything accidentally even. There are people that take that class over and over and don't get better. Yeah, trust me, that's a derivative. Yes, I was watching the Rangers game at the same time, but this was okay. Step 3, plug in the equilibrium. This problem came from the book. I don't like the fact that this is the origin, because the origin is not always the equilibrium. And this works. Like if you don't have the origin, you don't have to shift any equations. You just plug in the equilibrium. It just happened to be. And you have to do this because you're linearizing around something, because the model itself is not linear, so you need to linearize around something. So you choose the equilibrium point because that's kind of an important point. It's called a critical point. In fact, your book calls it a critical point. I've been calling it equilibrium point. Critical point from back when you were kids and were in calculus and did the derivative equal to 0. Okay, so that thing, I plugged it into Mathematica and said, crank me out the eigenvalues, please. So, step 4, find the eigenvalues. Tell me before I do this, you saw that picture. You already saw the answer. You saw spiraling motion. What kind of eigenvalues do you think you're going to get? You're going to get something with a real part going to be positive because it's not heading towards, the arrows were all going away from the origin. Are you going to get complex ones? Where do you get spiraling motions? Complex. So you expect to get something with a positive A and a non-zero B. That's what I would expect. Let's check if Mathematica got it right. Yep, it did. And I expect spiraling away because they're complex. But we already saw the solution. As you pointed out, it missed the whole circle business. So I didn't get everything from this. And I'm going to break that video up because that's going to be way too long.